Ever wondered how data travels in a network? In the vast digital universe, data is always on the move, journeying across networks like invisible messengers carrying valuable information. This journey is far from random. It's a well-orchestrated dance, guided by some key players. Two of the most crucial players in this dance are switches and routers. Imagine a bustling city. The data is like the traffic, constantly flowing, and switches and routers are the traffic controllers, ensuring everything gets to where it needs to go, efficiently and effectively. Without them, our data could end up lost or delayed, causing chaos in our interconnected world. Switches and routers are the unsung heroes of the digital world, tirelessly working behind the scenes to ensure our emails, messages, and videos reach their destinations. They keep the digital city moving, maintaining the flow and rhythm of data traffic. Now, let's dive deep into the world of switches and routers. Switches are like traffic cops of a network, directing data where it needs to go. Imagine you're at a bustling city intersection. There's a myriad of vehicles all trying to get to different locations. Without a traffic cop to guide the traffic, it'd be utter chaos. That's the role of a switch in a network setting. It directs the flow of data, ensuring a smooth, efficient, and orderly transmission across the network. But what exactly is a switch? A switch is a fundamental piece of networking hardware that connects devices on a computer network. It uses packet switching to receive, process, and forward data to the destination device. Now let's delve a bit deeper into the role of switches. They are primarily used to create a network. Devices are connected to a switch, forming a local area network, or LAN. This connectivity allows for communication between devices, whether it's sharing files, printers, or other resources. Switches also play a critical role in managing the flow of data. They ensure that these data packets reach the intended recipient and not to all devices on the network. This targeted approach optimizes network efficiency and enhances security. Another key function of switches is their ability to minimize collisions. In a network, collisions occur when multiple devices send data simultaneously, leading to data packets clashing with each other. Switches help avoid this by providing a unique, direct path between source and destination devices. And what about the speed of data transmission? Well, switches have got that covered too. Modern switches operate at high speeds, facilitating faster data transmission and thereby improving overall network performance. So, in essence, switches act as the nerve center of a network. They connect various devices, manage data traffic, enhance network efficiency, and speed up data transmission. By now you might be thinking, wow, switches sure do a lot. And you're absolutely right. They play an essential role in making our interconnected world run smoothly. So, switches ensure that data reaches the right device within a network. But how do switches know where to send the data? Well, the secret lies in something called a MAC address. Each device on a network has a unique MAC address, and switches use these addresses to direct data to the right place. Now you might be wondering, how do switches learn these MAC addresses? When a device sends a message, the switch notes the device's MAC address. This address is then added to a switch table, a kind of map that the switch uses to know where to send data. The switch table lists the MAC addresses of all devices connected to it, along with the port number that each device is connected to. Imagine you're at a party, and you're trying to find your friend. You don't know where they are, but you know they're somewhere in the room. You start asking around, hey, have you seen my friend? Eventually, someone points you in the right direction. That's kind of like how a switch learns a MAC address. When a new device connects and sends its first message, the switch doesn't know where to send the data. So it broadcasts the message to all connected devices. When the intended recipient responds, the switch notes the device's MAC address and port number. This information is then stored in the switch table. The next time the switch receives a message for that device, it doesn't need to broadcast the message to all devices. It knows exactly where to send it. So essentially, switches learn by doing. They build their switch table through experience, adding new MAC addresses as new devices connect and send messages. It's a bit like a postman learning the houses on his route. The more he delivers, the better he knows where each house is. Over time, the switch table becomes a comprehensive guide to the network. It enables the switch to direct data quickly and efficiently, keeping the network running smoothly. So, switches are pretty smart, aren't they? Well, They certainly know their way around a network, and that's what makes them such a crucial component in networking. Now, what if the data needs to go outside the local network? That's where routers come in. Routers are like the postal workers of the internet. They're the devices that make sure your data gets to where it needs to go, whether that's to the printer in the next room or a server on the other side of the world. But how do they do that? Well, it's all about the IP addresses. Every device that connects to the internet has a unique IP address. It's like your home address, but for your computer, smartphone, or any other device. This address is used to send and receive data over the internet. So when you want to visit a website or send an email, your request is sent to your router. The router's job is to read the IP address of the destination and figure out the best route to get there. It does this by connecting to different networks, just like how a postal worker might decide to take a different route depending on the traffic or the time of day. The router also keeps track of all the devices connected to it and their respective IP addresses. So when a packet of data comes in, the router checks its list, finds the matching IP address, and sends the data to the right device. But that's not all. Routers also provide a layer of security for your network. They have built-in firewalls that can help protect your devices from unwanted intrusions. They can also be set up to control which devices have access to the internet and when, which can be useful for managing your children's screen time or ensuring that your work computer is the only one that can access sensitive data. So, routers are more than just a way to connect your devices to the internet. They're the gatekeepers, the traffic directors, and the security guards of your digital world. They ensure that your data gets where it needs to go, safely and efficiently. So, routers are the gateway to the outside world. But how do routers figure out the best path for the data, I hear you ask? Well, my friends, it's all about routing tables and routing protocols. In the intricate world of networking, routers function as our traffic directors, guiding data packets along the most efficient routes. At the heart of this operation are routing tables, the router's internal map, if you will. These tables are essentially databases that store information about network paths. Each entry in the table consists of a destination network and the next hop to reach that network. Now, you might wonder, how does the router know which path is the most efficient? This is where routing protocols come into play. These protocols, such as RIP, OSPF, and BGP, are the rules of the road, providing routers with a set of guidelines on how to communicate with each other, share information, and decide on the best path for data packets. RIP, or Routing Information Protocol, is one of the oldest protocols. It uses a hop count as a routing metric to limit the network size. OSPF, or Open Shortest Path First, is a more complex protocol that considers several factors, such as the type of service and link states, to create a topological database of the network. And then there's BGP, Border Gateway Protocol, the protocol that rules the internet. It makes routing decisions based on paths, network policies, or rule sets configured by a network administrator. These protocols update the routing tables as network conditions change, ensuring that the data journey is as smooth as possible. For instance, if a network link goes down, the protocols quickly update the routing table, and the router immediately starts directing data along a different path. So, routers do much more than just act as gateways between networks. They're like the brain of the network, constantly analyzing, learning, and adapting to ensure that data is transmitted as efficiently as possible. So, routers are not just gateways, but intelligent pathfinders. So, we've taken a journey through the world of switches and routers. In our exploration, we've come to understand the critical roles these devices play in the realm of data transmission. Switches, beautifully designed for their purpose, enable communication between devices on the same network. They smartly manage traffic, ensuring that data packets reach their intended destinations promptly and efficiently. Then we've got routers, the masters of networking. These devices connect multiple networks, directing data packets along the most efficient paths to their final destinations. They're like the traffic cops of the digital world, maintaining order and ensuring everything runs smoothly. We've also delved into the complexities that lie beneath their seemingly simple exteriors. Their intricate operations, from managing data traffic to securing our network connections, are truly fascinating. And that's how data travels in a network, thanks to the hard work of switches and routers. We hope this journey has enlightened you about the unseen heroes of the networking world.